Okay, this has been from the world's smallest lab. I think I found a conclusive way to show that the motor system does have gain in it. And what we have here is my simple motor test bed, the 2 driver coils, and just 1 generator coil. These coils are wired in parallel, not in series. I wired them in parallel to get lower impedance. I'm not worried about the voltage as much as I'm wanting to just see what I can get out of it, because I am wiring the output of these 2 coils and this bridge rectifier and this capacitor in series with the power supply back here, and this voltage plus the power supply voltage from the wheel will show the total voltage on the system that it's running on. The significance is, if I run this system on, I'm going to set it to 14 volts, give or take. You'll see it's on 14 volts, no current right now because it's not running. And the meter here is actually, the meter you can see is, let's crank it on up so this meter is much more accurate than the meter on the power supply is. Very close to 14 volts now. Very little voltage. This is leakage voltage left in the cap from a previous run. And what happens is, now when I start the motor generator, you'll see the rails. This is the voltage that the motor sees. Now this is the power supply. It's actually 14 volts. You can see how far it's off there, or I'm losing that much in all these cables dangling around here. But as the generator kicks in and this voltage comes up, it will add to this voltage and give you a sum voltage. Now the test to see if we got gain is, if I run the motor strictly on this voltage and the generator unloaded, it runs approximately 220 RPM slower than with this boost circuit in here. Now it's not conclusive proof that there's gain, but it's the closest thing I've got to proving to me that something positive is happening here. So let's give it a spin. Let it spin up. It takes it a while, and you can see the battery the power supply voltage coming up, and you see behind it the rail voltage is going up to the motor. It's already 2 volts above the power supply that's powering this device. And as this thing winds on up and gets up to approximately 2500 RPM, it'll take it about a minute to get up to speed. If I look at it here, it's already up to 2000 RPM, and it's winding up. The sweet spot on this motor is around 14 volts, 2500 RPM. Now you can see now that I have got 4.8 volts coming out of the power supply. 4.9, it will actually level out at about 4.45, 4.46 volts when it gets all the way wound up here. It takes it a while because as the charging drops off and it levels off at the top. Right now it looks like if I ran 3 coils here, I could break even and it should self-run, but I'm not certain because there's more drag when you start adding this. And I've discovered it's absolutely imperative that this coil mount is absolutely rigid. If it gets harmonics and vibrations going, it'll feed into the wheel and you won't believe the racket this thing can make. But now you can see 5.346, 19.6 volts. The thing is 19.67 volts that it's running on, and then the power supply down here is still the same. But this, and let's see what it's peaked out at now, RPM wise. Yeah, 2502, 04, 2505, and it's still winding up a little bit. But it will, now just to show you what I'm talking about, if I unhook I'm going to take the little generator supply out and just run it on the motor, just on the 14 volt supply. You can see we're running at 14.33 volts now, and the cap is just floating now. The capacitor here for the power supply is just floating, and it's actually charging on up because there's no load on it now. It'll charge on up to, I got it written down here somewhere, it's 9 or 10 volts. But you can see now, let's test the RPMs. Okay, 2352, we were 2501, and it's still climbing a little bit, but there is at least a few percent difference that there is some current gain in this device with the generator under load. So that's just what I'm wanting to show. I don't know if I can add a couple more coils. I had all the coils on the other day and it was just it just vibrated to death. So I'm going to try to add one coil braced at a time and see how everything pans out. Right now the power supply with these two output coils in parallel is giving me 8.71 volts. Now the fun thing is I can wire it back up into this with this voltage, and we'll go back into here and you'll hear it wind up now. You can hear it wind on up. I'm pretty sure you could hear that there, but anyway, and the voltage again stabilizes around 5.41. Looks to be about 70 milliamps from the series circuit, 19.72 volts on the motor. So anyway, that's what I wanted to show today. This has been worn out K4ZEP from the world's smallest and getting smaller every day lab. Take care. Goodbye.